Today we are going to discuss about the real numbers. Before going to discuss about the real numbers, let us have a recap about the various number system. The first number system is the natural numbers, and the natural numbers are denoted by the letter n. The natural numbers are nothing but the counting numbers which starts from 1, 2, 3 up to so on, and the smallest natural number system is 1, and there is no largest number. Here the first number system is natural numbers. After that we will get the whole numbers, and the whole numbers are denoted by the letter W. If you add 0 to the natural numbers, we will get the whole numbers, and the whole numbers will start from 0, 1, 2, 3 up to so on, and the smallest whole number is 0, and there is no largest whole number. So from this we can conclude that all natural numbers are whole numbers, but all whole numbers need not be a natural number. Example is 0. So the next number system is whole numbers, and after that we will get integers, and integers are denoted by the letter I or Z. If we add negative numbers to the whole numbers, we will get integers 0, 1, 2, 3, here -1, -2 and -3. So here the next number system is integers, and you already studied about various properties of natural numbers, whole numbers and integers in the previous classes. And the next number system is rational numbers, and the rational numbers are denoted by the letter capital Q. And how do you define rational numbers? If you consider any two integers, if you write those integers in the form of the fraction, then we call it as an rational numbers. Let us consider 1 and 2. We know that 1 and 2 are integers. If we write those integers in the form of the fraction, either 1 by 2 or 2 by 1, we will get the rational numbers. So we can define rational numbers as, if you consider any two integers, here consider P and Q are integers, and we have written these integers in the form of the fraction, and here one more condition will be there. Let us consider two numbers 0 and 5. We can write 0 and 5 as 0 by 5 or 5 by 0. You know that the value of 0 by 5 is 0, and we cannot define the value of 5 by 0 since this is undefined. You know that if the denominator is 0, the value is undefined. So while defining the rational number, we have to consider two integers P and Q, and we have to write that numbers in the form of the fraction, and the denominator should not be equal to 0. This is the condition we have to mention by defining the rational numbers. What are rational numbers? If you consider any two integers, we can write those integers in the form of the fraction, and the denominator should not be equal to 0. So the next number system is rational numbers. Now we are going to define the rational numbers in a different way. So what are rational numbers? If you consider any two integers, if you write those integers in the form of the fraction, and the denominator should not be equal to 0. So here define rational numbers in the other way. So how do you define the numbers which are either terminating or non-terminating, repeating decimals, are called rational numbers. What are rational numbers? The numbers which are either terminating or not terminating repeating decimals are called the rational numbers. To understand this definition, let us consider few examples. You know that 1 by 2 is a rational number. Here the denominator is not equal to 0. What is the value of 1 by 2? The value of 1 by 2 is 0.5. Here you can observe that after the decimal point it has an end. So the meaning of terminating is nothing but ending. Here after the decimal point it has an end. So we can say that this 0.5 is a terminating decimal. Now consider the value of 1 by 3. What is the value of 1 by 3? You can do here. Here you will get 0, 3 3 is 9. Again you will get the remainder as 1. Keep 0. Again 3. So here you can observe that this 3 is repeating here. So what is the value of 1 by 3? You will get 0.3333 up to so on. Here you can observe that after the decimal point it does not have any end. So we can say that it is a non-terminating decimal. And here in the definition you can observe that what we have written non-terminating repeating decimal. So here you can observe that after the decimal number, the number 3 is repeating here. So we can write this one as 0.3 bar. Which number is repeating here? That number you have to keep bar over that number. So you can define, if you consider these two examples, the value of 1 by 2 which is 0.5 which is a terminating decimal. Here if you consider 1 by 3 which is equal to 0.3 bar which is not terminating repeating decimal. So these two are the examples of the rational numbers. So after that, irrational numbers. And the irrational numbers are denoted by the letter Q dash. So the irrational numbers can be defined as the numbers which are non-terminating, non-repeating, decimals are called irrational numbers. Consider the example as 1.414 up to so on. Here you can observe that after the decimal point it does not have any end. So we can say that it is a non-terminating decimal. And after that, after the decimal point, no number is repeating here. So we can say that it is non-repeating decimal also. So it is an example of irrational number. Let us consider the value of root 2 which is 1.414. If you consider the value of root 3, what is the value of root 3? 1.732. Here you can observe that if you consider these two examples, after the decimal point it does not have any end. It is a non-terminating decimal. And after the decimal point, no number is repeating here. So we can say that it is a non-repeating decimal. These are the examples of the irrational numbers. Now in your class you are going to learn how to find the value of root 2 and how to represent these irrational numbers on a number line. And after that, these all numbers, these natural numbers, whole numbers, after that integers, after that rational numbers, after that irrational numbers, all these together we call it as a real numbers and it is denoted by the letter R. Now let us discuss about how to represent these irrational numbers and the rational numbers on a number line. Here, if you want to represent rational numbers on a number line, just you have to draw the number line first and you have to mark the numbers. if you want to represent 1 by 2 on a number line, here the first step you have to divide, you have to check what is the denominator. Here you can observe that the denominator is 2. So we have to divide each unit into 2 equal parts. Here we consider this as 1 unit, and up to here this is 1 unit, and up to here this is 1 unit. Now since the denominator is 2, we have to divide this unit into 2 equal parts. 1 and 2, after that here 1 and 2, 1 and 2, 1 and 2, 1 and 2, here 1 and 2. Now you have to check what is the numerator here. Since the numerator is positive, you have to go to the right side of 0 to 1 step. Here you can observe that here since the number is 1, you have to move to 1 step. So this is the representation of 1 by 2. If you want to check it, you can write 0 as 0 by 2, and after that you will get 1 by 2. After that you will get 2 by 2, which is equal to 1, and after that you will get 3 by 2, and after that 4 by 2, which is equal to 2. Now here let us consider one more example, 2 by 3. If you want to represent this 2 by 3 on a number line, what is our first step? You have to mark the numbers on a number line, and after that you have to check what is the denominator. Since the denominator is 3, you have to divide each unit into 3 equal parts. 1, 2, 3, 1, 2, 3, 1, 2, 3. Here also 1, 2, 3, 1, 2, 3, 1, 2, 3. Now you have to check what is the numerator. Since the numerator is positive, you have to go to from 0, you have to move 2 steps to the right side of the 0. Here this is 1 and this is 2. This is the value of 1 by 2. 2 by 3. If you want to check it, you can write this one as 0 by 3. This is 1 by 3, and this is 2 by 3, and this is 3 by 3, which is equal to 1. Like this you have to represent rational numbers on a number line. Here we discussed about the rational numbers on a number line, which is the terminating decimals. Now let us represent irrational numbers on a number line. Suppose if you want to represent root 2 on a number line. Here, if you want to find the value of root 2, just we need to follow some steps here. Write here 2, and after that keep here decimal point. Since we are finding the square root of the number, you have to keep 2 zeros and you have to keep bar over that. And you have to find the number such that if you multiply the same number, you have to get a number such that that number should be less than 2. Here if you consider 1 and 1, you know that 1 into 1 is 1. After that, if you consider 2 and 2, 2 into 2 is equal to 4. You can observe that it is the biggest number compared to 4. So you have to consider here 1. Here 1 once 1. Now you have to subtract this number. What you will get here 1. Since we are finding the square root of the number, you have to keep these 2 zeros down. And after that, the next step is you have to double the number. What is the 1 plus 1, which is 2. Again you have to follow the same procedure. You have to write here one number such that you have to write the same number here. If you multiply those two numbers, you have to get the number which is less than 100. Now consider here 21 into 1. Here you have to consider the same number, which is 21. Here after that 22 into 2. You will get here 44. And after that here 23 into 3. You know that here 3 into 3 is 9, 3 to 6, 69. Now consider 24 into 4. What is the value of 4 into 4? Which is 16. Here 4 into 2, which is 8, which is 9. Now consider 25 into 5. What is the value of 25 into 5? Which is 125, which is bigger than 100. Now you have to consider 24 into 4. So here write 4. Since here decimal point is there, you have to keep here decimal point. Here write 4. And after that 24 into 4, which is 96. Now you have to subtract the number. You know that 100 minus 96 is 4. Now you have to keep these 2 zeros down. After that, again the same procedure. You have to double the number. Here 24 is there. Here 4 is there. Add what you get here 28. Again you have to find one number here such that if you multiply those numbers, you have to get the number which is less than 100. After solving again here, you get 1. Here write here 1, 281. Now again subtract. After solving like this, you will get the value of root 2 as 1.414 up to so on. How do you find the value of root 2? Let us discuss again. If you want to find the value of root 2, here, just here write the number 2. After that number, keep the decimal point and keep zeros, and after that keep bar over that, and you have to write one number such that if you multiply the same number, you have to get the number which is less than 2. Now here if you consider 1 into 1, you will get 1. If you consider 2 into 2, you are getting 4, which is bigger number, so you have to consider 1 and 1. After subtracting, you will get 1, and you have to keep these two zeros down since we are finding the square root. And after that, you have next step is you have to double the number, which is 1 plus 1, which is 2. Now again the same procedure. You have to write here one number such that if you multiply those numbers, you have to get the number which is less than 100. Now here if you consider 24 into 4, you are getting 96. If you consider 25 into 5, you are getting 125, which is the largest number compared to the 100. So we have to consider here 24, which is 4, which is 96. Again after subtracting, you are getting 4. Now what is the next step? You have to double the number. 24 plus 4, which is 28. Again you have to write one number such that after multiplying, you have to get the number which is less than 400. So what is the value of root 4? Which is 1.414. Now if you want to represent this on a number line, let us draw the number line first and keep the points as 0, 1, 2, 3, here 1, 2, 3. Now here if you want to represent root 2 on a number line, you need to know about the Pythagoras theorem. Here if you want to represent root 2 on a number line, you need to know about the Pythagoras theorem. What the Pythagoras theorem states, you know that the Pythagoras theorem is applicable only for the right angle triangles. What is right angle triangle? If one of the angle is 90, we call it as a right angle triangle. Here, what the right angle triangle states, you know that the longest side in a triangle we call it as an hypotenuse. And what the Pythagoras theorem states, the hypotenuse square must be equal to the sum of the other two sides. Here, mark it as A, B, C. So, what is the other two sides? BC square plus AC square. This is the Pythagoras theorem states. By using this Pythagoras theorem, you can represent this irrational number on a number line. Now, you have to check such that consider the right angle triangle. You have to get the hypotenuse as root 2. Which numbers you can choose here? The other two sides such that you are getting the number as root 2. You have to check. This is the rough figure. Here, if you consider here 1 as one side and the 1 as the other side. By using Pythagoras theorem, you can observe that since here we have to get here as the value as root 2. Now apply Pythagoras theorem here. What the Pythagoras theorem states, AC square is equal to AB square plus BC square. What is the value of AB here? 1, which is 1 square. Here what is the value of BC? Which is 1, which is 1 square. You know that the 1 square is 1 and here the 1 square is 1, which is 2. You are getting the value of AC square is equal to 2. Now what is the value of AC here, which is root 2. Now here we are getting this as the root 2. So which two sides you can take here? We can take 1 and 2, 1 and 1 as the other two sides, so that we are getting the hypotenuse as root 2. Now we have to represent this right angle triangle on a number line. Here you can observe that from 0 to 1, this is 1 unit. Let us consider this as 1 unit. Now here, since you can observe that we are representing this right angle triangle on a number line, here draw 90 degrees with the help of the protractor. And after that, At this point, mark 1 unit with the help of the scale. Now join this one. So this is 1 unit and this is 1 unit and this is root 2. Right? Like this you can represent this root 2 on a number line. Since we are representing root 2 on a number line, here let us consider by using compass, take this as a center and this as a radius. Now here take this as a radius and mark here 1 arc. Here where this mark touches the number line, that will be the value of 1.414. You can check it. Like this you can represent root 2 on a number line. Suppose if you want to represent root 3 on a number line. Right? Here you know that the value of root 3 after solving the process you will get 1.732 like this. So if you want to represent this root 2 on a number line, here you can observe that up to here this is the value of root 2. Here at this point you can draw one right angle here by using the protractor. Draw here one right angle here and here mark as 1 unit. Why? Because if you consider the right angle triangle, here we have to get the value as root 3. So which numbers you have to choose here such that you will get the value as root 3. Let us consider here root 2 and let us consider here 1. Now by using the Pythagoras theorem, you can write the hypotenuse square is equal to the sum of the squares of the other two sides. Here what is this value, which is root 2 whole square. Here which is 1 square. You know that this one will get cancelled. You will get here 2 and here this is 1. The value which is 2 plus 1 which is 3. So you are getting AB square is equal to 3. What is the value of AB, which is root 3. So if you consider root 2 and 1 as the other two sides, we are getting the hypotenuse as root 3. Now you have to represent this in a number, on a number line. So here we already represented root 2 on a number line. Now at this point you have to draw one right angle triangle. So at this point with the help of the protractor, draw 90 degrees and mark how much length we have to mark it here, 1. So here mark 1 length and join this one. Now we are getting this as root 3. Since we want to represent root 3 on a number line, at this point take as a center and this as a radius and mark one line arc here. Where it touches the number line, that will be the value of root 3, 1.73. Like that you can represent any rational numbers on a number line. Now up to now we discussed what we discussed: natural numbers, whole numbers, integers, real numbers, irrational numbers, and the representation of rational numbers and irrational numbers on a number line. Now in the next class we are going to discuss few problems about this topic and we are going to discuss real numbers.